Hi guys, welcome back to the channel. In this video we are going to discuss about asynchronous counter application, that is ripple counter as frequency divider, and also in this video we are going to discuss cascading of counters. So let's see how to do that. First of all, we need to understand the asynchronous counters as frequency dividers. So I took 2-bit asynchronous counter. You know about asynchronous counter. So the previous output would be clocked to the next flip-flop. So that is the basic of asynchronous counter. So in the clock pulse, if you suppose observe that I am passing the frequency of f in the output q1, so not q0, in the output final output q1, I am going to have the final frequency that is divided as f by 4. That is a very important point. Why this frequency is divided in asynchronous counter? So this is the application. Now we are going to analyze this frequency, why this frequency is dividing with the help of timing diagram analysis. And also one important point is this is mod 4 counter. Mod 4 counter is divided as f4 frequency. If you see the timing diagram analysis of 2-bit asynchronous counter, so this is that. So we are passing clock. For the clock, if you see for the each falling edge, means the time between two falling edges, if you see that, compare the time, that is t. If you see the first output for the first flip-flop, that is q0, the time would be 2t. For the second flip-flop output, the final output q1, the timing is 4t, you can see over there. Basically, one high level, one low level is known as one full time period, or one full square means one full wave. Like that we are going to see. With the comparison of clock, I am going to take the q0 and q1, so that I am going to have q1 as 2t, because that is 2 high levels and 2 low levels for according to the clock, and q1, that is 4t. So we got the time. So for the frequency, if you observe, that is the simply inversion or the inverse of the time. So the first one, clock itself, the frequency 1 by t, that is simply I took as f. So in the comparison of q0, that is 2t. So 1 by 2t means what? That is f by 2. Means what is meant by that? The frequency is divided by 2. So then if you see the output of q1, that is frequency is divided by 4. Means 1 by 4t, that is frequency is divided by 4. So you can see that gradually decreasing the frequency in the last output of the last flip-flop. So likewise frequency will be divided. So with the help of 3-bit ripple up counter also now we are going to understand. So in the first clock pulse of the first flip-flop, I am passing directly f. So that is the clock pulse directly I am sending. So in if you see in the third flip-flop, the q2 output, the frequency of that is f by 8. So this is the mod 8 counter. So we are going to get the q2 output as f8. So that is f by 8. We can also have the timing diagram analysis and we can cross check that. So if you see the clock pulse, the falling edge and rising edge means the high level and low level I took as time period t. So in the q0, if you see the 2t, the q1 if you see the 4t, if you see clearly the q2, that is as 8t. So in the same way we can say the frequency is 1 by time period. For the clock we have frequency f. For the first flip-flop output q0, that is frequency is f by 2. For the q1 f by 4. For the last and final flip-flop q2 output, the frequency would be f by 8. Similarly for the mod 16 counter, that means 4-bit counter, if you are sending f as clock pulse, means the frequency of clock is f and the final frequency of final output, that is q3, at that position we are going to have the clock, means that q3 output frequency would be f by 16. That is the denominator is equal to the modulus of the counter, means how many states it is counting, that is the frequency that is divided with the frequency. So we can observe a pattern in this. For the mod 4 counter, we are having at the final output, that is f by 4, means the frequency is divided to f by 4. In the mod 8 counter, the frequency is divided to f by 8. In the mod 16, the frequency is divided at the final output f by 16, and so on. How many states the mod means the counter is calculating, that is the frequency that is divided with at the last flip-flop's output. So that is the same thing written over there. At the final output of the counter, the frequency would be divided as f by mod value of the counter. So with this only we are calling that ripple counter as frequency divider. So this is the application of counter. If any of the time we want to divide the frequency further and further, we can use the ripple counters to have this frequency division. Okay, we have understood. At the last flip-flop, the frequency would be f by modulus. So in the mod 10 also, if you observe, we have 4 flip-flops. So mod 10 means what? Basically it will count up to 10 states. So according to our requirement, we have modified that as Total this is a mod 16 counter, but according to our requirement with the help of NAND gate we have modified the circuit to mod 10 counter. It will calculate up to mod only 10 states. So if I pass the frequency f in the clock of the first flip flop, you can observe in the Q3 output we are going to get f by 10 frequency of output Q3. Not we are not going to get f by 16 because this is the mod 10 counter, because according to the formula. Similarly, if you have mod 20 counter, if you pass frequency f in the output frequency, you are going to get f by 20. So the same thing that we have up to saw. Now we are going to understand the cascading of the counters. So basically, if you cascade the counters of mod 4 counter and mod 5 counter, if you pass the frequency of f in the output frequency, again you are going to get f by 20 frequency. So why this is happening? Because if you cascade any of the two counters, the output or the main frequency or the main modulus of becomes mod 4 into 5, that is mod 20 it becomes. So that is the reason in the final output we are going to get the final frequency as f by 20. So that is the thing that I am saying about. So if you cascade in the general situation, the mod m and mod n, the final output or the final cascaded modulus would be mod m into n. So in this case, mod 5 into mod 4 is that is mod 20 counter. So that is the reason the frequency is f by 20. So if one more important thing, if you interchange the modulus counters also, there is no changes in that, because both are ultimately m into n, n into m, both are same. That is the reason if you interchange the positions of modulus also, the final frequency would be f by 20, and final modulus of the counter would be mod m into mod n, that is mod 20 only. So finally, I hope you understood this video. Thanks for watching up to now.